Just like to talk to you guys about this new product. It's DPS5015. It's advertised as a constant voltage, constant current, power, programmable control supply power module. What a mouthful. I have been waiting for something like this to come along for quite some time. It's actually quite a useful little device. It's basically a DC to DC buck converter. It's got a nice little display on it. I'll see if I can get in a bit closer for you there. And it's got some great specifications as well. Input voltage range from 6 to 60 volts. And it outputs up to 50 volts. Output current 15 amps, which is fantastic. And so that works out if at the maximum 50 volts and 15 amps, you can pull 750 watts through this device. You can see the specifications here. The size is quite a compact little device. It's supposed to have voltage and current resolution to 0.1 amps and volts. And yeah, it's just quite a nice little device. It's got like a rotary encoder here to let you adjust the settings, 3 buttons down the side, and a power button. So it's actually it's split in two. This is the actual control board that does all the work, and this is effectively the keypad that you can mount up somewhere else and use it. It's got two sort of ribbon cables that connect it. It does have these strange binding posts, which aren't, in my opinion, all that fantastic. But let's have a look at it. Okay, well, this is what I've built. Basically, I've got 2 of these things, and I've put them in this case. Pretty simple, just some banana plugs out the back, the 2 control pads on the front, and that's just a resettable fuse. Out the back, I've just got a Anderson connector there with some heavy gauge wire I use to feed the power in. Okay, let's open this up and I'll show you inside. Okay, this is what's inside, what I've built inside. So basically, as I said before, this is the input power. Use an Anderson connector, comes in this 8 gauge wire, comes into this awful big mess here. This basically is just where I've joined these 2 wires, and they come out as 4 separate wires. This is where it splits to power the 2 individual units that are in here. So this is coming out, just splits into 12 gauge wire. So the negatives obviously go straight to the negative input posts on these devices. The positives run through these fuses and then onto there. So I had a bit of trouble getting a fuse, which was, well, best I could do. So this is a 20 amp fuse. Let's see if I can get that to focus. I found a lot of trouble finding a fuse which was actually rated to 50 volts DC at 20 amps. So the local electronics store really had only AC fuses, and it is important that you get a DC rated fuse for these sort of projects. The outputs are over here. Let's see if I can get a bit closer and I'll show you these binding posts. So they're these sort of just things you can screw on a lug to. So I've just put these. I had to use these things. I've used the heavy gauge wire again. I think it's 8 gauge wire coming out of those, and I ended up having the outputs on the opposite side to the boards, just so I didn't have to cross the have this heavy gauge wire do such sharp turns in the box. So this module here, output comes out these sockets, so obviously the controls are also swapped over as well. So it's pretty simple on the inside. There's nothing, I haven't done anything amazing in here, but it works pretty well. So I'll put this back together and we can run it through its paces. Now I forgot to say that the device does come with these tiny little things to attach the wires to the device. I don't know if I'd like to be running 750 watts through that. I declined to use those. I bought some beefier ones. Okay, this is what I'm going to be using to power this. So obviously the input was up to 60 volts. I have this 48 volt supply handy, and it's fantastic 48 volt supply. Can supply up to 50 amps output at 48 volts. Yeah, so it's more than enough to run these. I actually use it on a also to power a battery charger, so it's got multiple uses for me. But when I saw these devices that were rated up to 50 volts output and 60 volts input, it immediately caught my eye because I knew I had this supply kicking around. This, the way I've got it hooked up, the output comes out these large binding posts, goes into this, I guess it's an 8 gauge wire again, and it just terminates in this 120 amp Anderson socket. Okie dokie, power supply's on. This is a moment of truth. We're going to see a big flash, or it's going to work, one or the other. Oh. Okay. Hey. Okay, so let's have a closer look at these modules. So we've got the two of them here. At the top is the set points. So this one's set at 14.2 volts, 15 amps output, and this is the current. This is what's the current state at the output post. So they're switched off. So 0 volts. 0 watts, and then down the bottom here is the voltage that each one's seeing at the input side. So seeing 18.8 volts there. This one's also seeing 18.8 volts. Switch it on. pretty much immediately comes up to the set point, so 14.2 on these ones. Looks like I got 28 volts on these ones. You've got no load on them, so the little capacitors just take a little while to discharge. This here shows whether it's in constant voltage or constant current mode. Okay, let's put some load on it and see what happens. Okay, this is what I use normally for basic load testing. It's just a high and low beam bulb from a car. You can run. It's got two filaments in it. One's rated at 55 watts and the other's rated at 60 watts. We can run both in series, or we can run either one by itself, or we could run them both in parallel. At the moment I've got them across these two terminals here. They're running in series, which means although this is a 12 volt bulb, to get it fully illuminated we'll have to power it up to 24 volts. Okay, let's what will we start with? So to change the voltage set point, just press this V button, and you'll notice that the little cursor appears on the hundredths of volts, and if you press the rotary encoder it jumps over to tenths of volts, or press it again and it jumps over to whole volts. And that when you turn the rotary encoder, that's the digit that it's adjusting. So if you want to do a quick adjustment, you can adjust in whole volts. Let's set it to, I don't know, 5 volts exactly, and we'll set the current limit at this stage. Let's turn it right down, I don't know, 0.5 amp. Sounds good to me. Okay, plug our load in over here. Let's put it down here. Let's try not to short it out on the top of this case. Let's turn it on, see if we see anything. Okay, so what have we got? So at the moment, power supply is outputting slightly over what I've asked it to, so it's doing 0.6 of an amp at 0.22 volts, and that's about 0.1 of a watt, and that's not enough to illuminate the bulbs at all. So I think we're going to need some more current. So we'll press the current adjustment and let's start dialing in some current. Oh, there we go. Turn it down a bit. So at the moment the set point's at 2.3 and it is doing exactly 2.3 amps, and it's at the 5 volts, so well, it worked out well. So it's in constant voltage mode at the moment. If I ask for more current, I'm not going to get it because the voltage is at its set point. Let's turn that down. Oh, excuse me. Let's say 2.5 amps. Let's go over to voltage now, and we can start bringing the voltage up, and that'll give us, so there's 6 volts, and we should be at 2.5 amps. It's actually outputting at 2.6 amps. I presume that's, interestingly enough, it's saying it's in constant voltage mode still, so it still thinks it hasn't reached the current set point. It's a bit strange. Give it a bit more voltage. Now it says it's in constant current mode. It's still showing nearly 2.6 amps when the set point is at 2.5. Okay, I'm just going to put the light bulb out of your vision at the moment because it's going to get pretty bright. Okay, let's have a... So that's a little bit strange. The set points... are being exceeded. Which is a bit of a worry. Okay, so it says it's in constant current mode. Well, let's play with the current and see what happens. So it looks like it's about 0.1 of a milliamp higher than it should be all the time. So if I take it up to 2.7, oh, now it's about right. What about if I take it down? 2.3, it's only about 2.4 is the actual. 2.1, it's showing about 2.2. Oh, let's turn it up. Actually, we'll set the voltage. So these things should be able to handle, well, say the car alternator was doing 14 volts, it should be able to do double that because they're wired in series. So I'll max this out at 28 volts. Hopefully that should... So we shouldn't be hitting a voltage limit anymore, so we should be on constant current, only looking at a constant current limit. Okay, so we'll bring it up a bit. So it should be at 3.9, it's at 3.99. So it seems to be always about 0.1 of an amp above what it should be. Okay, we're up to 150 watts now. You can hear the power supply fans spinning up a bit. That's not the fans on the little board in here. It's actually the fans in that Meanwell supply. Okay, and at this point it's limiting on voltage. We're still not at the full. Well. It's going pretty happily there. It's actually over the rated current, but I think it's still alright. Over the rated current for the bulb anyway. Okay, well that's interesting. So at constant voltage, I'm not even adjusting anything now. Take it down to 5 amps. Okay, well that's a bit strange. Let's switch that off. I'll plug it in onto the other one. Let's see if I've just got one dud module. So I'm changing the cables over at the moment. Just going to untangle them a little bit. Plug that in there. Okie dokie. It's 28 volts. Let's power it up. We're in constant voltage mode, so let's start limiting the current and see what happens. Let's take it to 5 amps again. Oh, look at that one. It's pretty much spot on. .3. And this is why you always buy 2 of every item when you buy something on eBay, especially this electronic stuff, because otherwise you've got no idea if one of them's faulty or not, or if it's just designed that way. Now if we go into the set menu, we can have a look at all the settings in here. I don't believe there's anything calibration in here that I can look at. I'll just run through them all quickly. So this is another way you can set the voltage and current set point. It does have an over voltage and over current setting. So if you set these, what happens is if your load exceeds a certain voltage or a certain current, the device will cut the power altogether, and that's useful. And you can also do the same with power as well. So you might have it set you don't want to exceed 100 watts of power. You can dial that in. If you do exceed it, it will shut it down. Let's just do that for fun. We'll turn it off. Let's go down and change this. 150 watts. Say 100 watts. So if I switch this on, it should immediately go to overpower protection. So you see it's got OP, which has come on. So again, you have to switch it on again, it'll shut down. So if I switch let's change the current set point, turn it down a bit, turn him on. Okay, let's bring it up. Still running. 70 watts. 80, coming up to 90. Oh, there we go. So it's immediately switched off. That's pretty good. Okay, that one works. Oh. I'll put this back up again. Okay. Well, what's the story with this one then? Let's put the load back into here and have a bit more of a play around. Has this one been knocked out of calibration? Certainly seems like it, doesn't it? One would think this would be a software thing, and that that isn't actually possible. Let's have a look at the actual real current going through these cables. Let's come out a bit. I've got a clamp meter. We'll zero it out. Let's grab a current reading on one of these cables. 5.06. Well, that's halfway between both of them. That does tell us much at all, does it? Oh well, actually it's 5.08. 5.06. I'll just zero it out again just to be sure. These DC things are always a bit strange. 5.05, and that one says 5.08. Turn it down a bit. Yeah, well, at least it's tracking fairly close to the real current, but it's still showing above what the set point is. Okay. Let's try putting some higher load through this thing and see if how well it fares at the 15 amp setting. Okay, here I've got a lithium iron phosphate battery. Conveniently has an Anderson connector on it. And we're going to use this power supply to charge this battery. Now, this battery is rated, well, it's a 40 amp hour battery. So charging it at 1C, I could safely put in 40 amps into it without any problems. The manufacturers recommend it be charged to maintain its longevity at 20 amps, which is at 0.5C. And we're going to see if we can put in 15. So all I've done is I've hooked up this connector that goes into the battery. We're all at 0 volts. We're going to have to change some settings here. I might do that before I plug it in. So for the voltage cutoff point, I don't want to exceed 14 volts. 14.2 is the, I'm going the wrong way there. 14.2 is, I think, the maximum for this battery, so I'll set this at 14 volts, constant voltage, 14.1. Let's start off with 3 amps, whatever, that sounds fine. Okay, plug it in, see if we see some sparks. No, I'm not dead yet. Okay, so what we've noticed is it's come up and showing the voltage of the battery now, even though it's not switched on. So it's currently at 13 volts. Let's turn it on. I think this battery's probably reasonably full, so we'll see what happens. Come on. Okay, so it's immediately come up. It's putting in 13.39. Supposed to be putting in 13.3. Let's adjust the current. Power supply's cranking up now. Okay, we're charging 15 amps. It's 200 watts. So far, so good. No smoke. So you can hear the fans in the big Meanwell supply picking up. Let's do some current measuring. Let's zoom out a bit. Okay. Let's have a look at the real current. I'll zero this out again. Yeah. Pretty much 15 amps running through those little wires. So, well, this will be interesting. So, what I might do, I'll see if I can move this around a little bit. I'm going to bring this supply into the picture. What I want to do is get a current reading on the output of this power supply. It'll give us an idea of the efficiency. Let's see if you can see that. No, not really. Okay, so hopefully you can see that. So it's about 14.46 coming out of the power supply. I'll just zero it again. Take another reading. .48. Righto, we'll call it 14.48 then. Yep. Okay, this thing's reading the voltage of the power supply at 48 volts. So we'll do 4.48, I think it was, multiplied by the 48.13 volts. So that gives us about, it's the Meanwell power supply is supplying 215 watts to both of these units, and this one is consuming 209.3 according to it. So we're losing about 6.3 watts in heat. 6.3 watts in total anyway. And that's not too bad. 6.3 watts out of 215, well, we'll say it out of 210 there. So 6.3 divided by 210. So 3% loss. That's pretty good. That's a pretty efficient boost converter, really. Okay, we're still at our 15 amps. Seems to be no problem. I can hear the fans in this thing here spinning now, very faintly. Can't really feel any heat coming out here, not that I expect to really, but yeah, it seems to be able to be to happily be able to do its rated current output quite easily. Well, why don't we really give it... I've still got my bulb plugged in over on this side. I'll just get that out of everyone's way. Let's put this one on as well. Turn up the current. Okay, so we've got 150 watts on one side, nearly 210 on the other. Power supply, it's not even straining, it's now down to its 48 volts. I'll just throw the clamp meter on this one again. Yep. Just zero that out. Grab a reading over here. Uh, 7.7 amps out of the this thing's, remember, capable of doing 50, so it's certainly not straining the Meanwell supply. Yeah, they're ticking away. It's quite nice. The only thing I do have a concern with, as I said, this module seems to be slightly above its set points. This one seems to be spot on. One of the other points I should note is that the person that's designed these modules He's on YouTube as well, so he seems to be responding to YouTube videos that people are putting out about these modules. So it'll be interesting to see his comments on why one of these modules is a little bit different to the other one. Now, I'm going to switch these off. I'm going to unplug the battery, so I don't want to, I don't know if this is safe to power off when there's a battery attached. So this is the instructions that come with the device. There are a few bits in red. Most of it's Chinese to me. So I guess this is I was trying to look at, you need to make sure the input voltage is 1.1 times higher than the output voltage. That's why it's 60 volts input and 50 volts output. And for larger currents, pay attention to heat elimination. So I didn't have any problems with that, but my box does have ventilation slots in the side. Doesn't seem, let's have a look at the other warnings it's got. This module has reverse connection protection and output short circuit protection. You must be in strict accordance with the connection description to connect. If you connect the supply power with the output, the module will be burnt. Now, I'm not exactly sure what that means. So, does that mean that I shouldn't be plugging in a battery into the output? Well, obviously I just did, and it didn't seem to be a problem. Maybe it's when you need to have the module powered up with an input voltage which is higher than the output voltage before you plug it in. That's highly likely. Again, I'm not exactly sure what that means, but I'm just going to make sure that I've got the input voltage on and that it's higher, at a higher potential, 1.1 times higher than anything I plug into this output if I'm charging a battery, just to be on the safe side. That's what I take it to mean. Hopefully the person that built this device will be able to comment and give us some more details. When we powered it up before, it does have a welcome window which tells us the firmware version. I'm going to, just for the sake of completeness, I'm going to power these off and on again. Sorry about that. And we'll have a look at the firmware version. Just trying to get these Anderson connectors out. Okay, so it's unplugged now. It's running down the capacitors. There you go, it's off. Okay, I'm going to plug it back in and we'll see it boot up from scratch. Okay, these are on firmware version 1.1. Both modules are the same. Okay, so overall I'm pretty happy with this little build. Now these modules don't appear to be the best choice if you want to use them as a very accurate power supply, and you know, I wouldn't expect them to be. You know, if you want to buy a power supply which you can control the current and voltage very, very accurately, then you can buy them, you know, commercial lab power supplies. But those sort of devices don't output 15 amps of current. And you know, internally they're designed a lot differently as well. So for a device that can do 15 amps of current, you know, you're probably not going to be needing things to be that accurate. Well, I'm not anyway. Just keep it in mind, I guess, if depending on what your use case is, if you need very, you know, I don't know, I guess if you're doing a 1.2 volt rail or a 3.8 volt rail on something which is sensitive, you probably want to be cautious. And especially if you have something which, you know, you don't want to exceed a certain current on, you know, that needs to be very accurately controlled. But just test your device out. They seem to be working fine. Another thing I will point out is that in a commercial lab power supply, if you have two outputs on it, they're completely isolated outputs. You can use them, you can parallel them up, or you can use them in series, and that's no problem. Whereas these are not isolated, these cannot be used together. I did ask in another forum post the maker of these whether they were able to be serialized or parallel, and he said no, definitely not, it's part of the design. Just for completeness, I'm just going to have a bit of a fiddle here. So this is just on voltage setting. So if I go between the two negative points here, there's no voltage difference at all. I'll just switch them on. So even with them switched on, the negatives have got no voltage difference, so they're obviously a common negative. Difference between the two pluses, so I'm seeing 13.91 volts, which happens to be obviously the difference between 28 and 14 volts. So they're, you know, obviously the negatives are commoned up here. I think normally if you had a power supply which only had the negatives commoned up, you could run them in parallel, but I believe he said that's not allowed, and that could be because he's doing the current sensing on the negative side of the supply. So if you have two negative paths, you won't get an accurate current reading. So it could be something as simple as that. I don't know, I'm not going to do it. Again, if you wanted to do something like that, go buy a proper isolated supply. Or the other way you could do it, of course, is you could run these off two separate isolated supplies themselves. So if you had two isolated power supplies feeding them, then of course you could use these as isolated supplies. Not the way I've got it set up though. Okay, so one last test I think I'll do is I'm going to plug my battery back into here. Obviously I'm going to plug these banana plugs in first, make sure they're the correct polarity. We've got it powered up. Should be safe to plug this in. Oh, I've got it switched on. I shouldn't have left it switched on. Anyway, well that's alright. Let's start taking the voltage down. I want to just see how, we know that the current is a little bit out on the set points. Let's see how accurately it can do constant voltage. So, a little bit closer. So we're at 13.8 is the set point, and it's going over that. That's a bit of a worry. You know, most of these things, you know, if you were charging a LiPo battery or something from this supply and it was going over voltage, that would be a concern. Let's just actually measure it now with the multimeter, just for fun. Where can I easily get the... I'll measure it on the top of the battery. This is not going to be exact, obviously, because there's going to be some voltage drop to that. Now here's the... Where's the battery there? So the battery's at 13.7. This is saying 13.8. That could just be voltage drop. I'll try and... I can get the probes in under here. There are... On these posts there are points where you can plug a wire in underneath. Try not to short this out. Well, that's not working. Oh, what have I done? So I just noticed that the lock has come on. So I think I must have been resting it on this thing. So hold it in again, and that disables the key lock on this. Okay, let's power this up again. Okay, let's get the lighting a bit better here. Sorry, the contrast is pretty bad on this multimeter. I think so multimeter's reading 13.42. The output of this is reading 13.4, 13.41 and 13.4. That's pretty good. Let's power it up. It's taking it up to 13.82. Interestingly enough, the multimeter is showing it as exactly 13.8. We kind of want to change the current. Put the voltage up a little bit, 13.9. Yeah, it's 13.9. This is showing a bit over. 14. We're at constant. Well, we should be at constant current now. It's still showing constant voltage on the readout, yet it's over the 15 amps. So you'd think it should be showing constant current here, and it seems to be in constant current mode because the voltage hasn't reached the 14 point. Let's voltage up again. 14.1. Now it's gone to constant current mode. Constant voltage, constant current, constant voltage, constant current. So there seems to be no. This doesn't change at all. So it's obviously in constant current mode because when I'm adjusting this, there's no change to the output voltage or the output current. It's just the display is just wrong. Okie dokie. Well, I can hear everyone screaming. Well, we know that one on the left is wrong. Why do we keep fiddling with that one? Why don't we try the one on the right? Well, let's try that. See if it's any better. Okay, let's set it up. Turn the voltage down to 14 volts odd. What do we say? Say 14 volts. I want to set my current to be 15 amps, no more than 15 amps, so I don't blow this up. Let's plug in our Anderson connections, making sure positive's positive. I'll plug the multimeter in again as well, so I'll loosen off these banana plugs. Shove these multimeter probes up in here. So let's see if you can see that. That's balanced there. Get the stuff out of the way. So it's obviously switched on. It's outputting 14 volts. I'll turn it off. Interesting enough, I haven't even got that banana plug plugged in. Okay. Let's think. We're switched off. Checking that's positive and negative. I don't want to have a high current accident. Plugging in the battery. Okay, so see if I can get it so you can read that. So this is reading 14.1, this is reading 14.0. It's switched off. Let's power it on. Okay, we're instantly into constant current mode. Output voltage is 13.87. This is 13.85. Pretty close. This is just slightly higher. Okay, let's change the output voltage. Bring it down a bit. Look at that. That's pretty much spot on. 13.8. That's pretty much spot on. Yeah, pretty much spot on. Constant voltage. Yep, so it shouldn't have switched. Very close to switching to constant current. So next, click. It's gone to constant current mode. Yep, that's the way I would expect it to behave. Looks pretty good. This is coming up near 14 volts now. My battery is, so I don't want to really push it above 14 volts, so I'm going to switch it off. Unplug the battery. Now I can take these banana plugs out. I always got to second guess myself. You don't want to have this plugged into the battery and have these banana plugs flapping in the breeze. You get a nasty surprise with a 40 amp hour battery shorting out. Okay, what do we know? Everyone asks me what I know. I always say very little. Okay, so we know that one of these modules seems to be different to the others. So one of these modules seems to be not behaving as well as it should. Now, I've actually seen this similar behavior on other people's YouTube videos. Other people have commented about it. So I'm not sure if it's a defective module or maybe it's a design problem where they have a lot of trouble or they're having trouble calibrating them or something like that. I'm not sure. We'll wait to hear back from the manufacturer and see if we can get some more information. Although, you know, from an overall point of view, I'm still pretty happy with these modules. You know, sure, they're not as accurate as they could be. You know, they're a, what are they? Probably a 7 out of 10. I don't know. And I'm a hard marker. They could be obviously a lot better if they were accurate. And to get the full 10 out of 10, that'd be great if they were able to be paralleled up as well. That'd be nice. So, yeah. No problems with overheating though, which is I'm surprised. I was expecting them to really struggle at the full 15 amps. Didn't see any problem there. I had a look at the capacitors in them earlier. They're rated apparently for the, you know, well over the 50 volts and 60 volts respectively, so there should be no problems there. Yeah, Nice little devices. Anyway, I'll call that a day. If you've got any comments or have any questions and would like me to do some further testing on these, let me know in the comments. Otherwise, let's be looking forward to hearing from the maker of these and see if he can provide any more information. Thanks for watching.